to start by just putting a grid on here, and I'm going to start with the absolute value graph in red. Okay? Then we're going to look and do this graph in blue, which is a review from the last section. And then we're going to do this graph in green, which is new. So we have our absolute value graph. If I wanted to do this blue graph next, I would notice there's a 1/4 out in front of the equation. So I can label that 1/4. Can you see that that would be a vertical compression? You're going to multiply your y coordinates by 1/4. And what is the 2 that's inside going to do? Okay. Is it going to be, first of all, horizontal or vertical? Horizontal. Is it going to be stretch, compression, or translation? Compression. So it's going to be a horizontal compression. Your x values are going to get multiplied by 1/2. So remember that inside that function, you're multiplying by the reciprocal. And the way that we're going to find out what the blue graph looks like is we're going to take some key points from our red graph, which is our parent function. Now, the most important point on your original red graph will be 0, 0. And then we're going to take 1 point from the right side and 1 point from the left side. Now, it doesn't matter which points you choose, but thinking about what we're going to do, we're multiplying the y by 1/4 and the x by 1/2. Can you see that you might want to choose 4, 4 and -4, 4, for example? Because those ones divide nicely by 4. Then to show our work, and I'm going to start it lower down here so that we have lots of room. I'm going to write out my 3 original points, -4, 4. And for our blue graph, I'm going to draw these blue arrows here. And above them, I'm going to say what I need to do. I need to multiply my y values by 1/4 and my x values by 1/2. Then find out where those points are going to go. Well, 0, 0 is going to stay 0, 0. Y by 1/4 will change these ones to 1. X by 1/2 will change this to 2 and this to -2. And so I can plot those points, 0, 0, 2, 1, and -2, 1. Now, the other day I talked about an E9 error when you didn't label your graph. Okay? Technically, my blue graph is labeled because as soon as I labeled this red point 4, 4, it tells you that each of these lines is 1. So then by indicating that 2, 1, that's good enough for indicating. Now, if you are any of you that personality type are like, no, I have to label the point, Mr. Jarrett. I just need to make sure that I put on here that this is 2, 1 and this is -2, 1. That's fine. You can label extra points as well.
So it's less about actually labeling a specific graph and more about giving the scale.
It's more about giving the scale. Somehow you need to indicate what the scale is on your graph with a number. It's not enough just to do ticky marks because it could go by 2s, could go by 4s, could go by 1s. So there's the blue graph. And then when we get to the green graph, Okay? We've already done the 1/4. We've already done the 2. Now, the stuff that's new is this +3 and this +4. The +3 is inside the function. It's going to be a horizontal translation. We're going to go 3 to the left, and the +4 is outside. It's going to be a vertical translation. You're going to go 4 up. And what we're getting to in this chapter is if you got that green equation right from the beginning, how would you go about doing it? You would have noticed there was a vertical compression, then a horizontal compression, then a horizontal translation, then a vertical translation. In fact, you would do that just like you read a book. You would go from left to right and label each of the things as they appeared. You would do the blue ones first, because as you're going from left to right, they appear first. And you do always your stretches and compressions first. So we did those already in blue. Then, after you've done your stretches and compressions, and this is what I'm going to show with these green arrows, is you can say, I need to go 3 to the left and 4 up. What's going to happen to these points now? 3 to the left will take me -3, 4 up to 4. 3 to the left, -1, 5. And 3 to the left, -5, 4 up, 5. And we can label those points on our graph -3, 4, -5, 5, and -1, 5. And so when we're going to be asked to just graph the green function directly, okay, we're not going to need to graph that blue one in between. I did the blue one in between just so that we could see it, okay? But we can just set up our points this way, describe our stretches and compressions first, then our translations. Look what happens to the points after the stretches and compressions, and then translate them left, right, up, and down after that. And you'd be able to go from your red graph to your green graph right away. Okay? The powerful thing about this is now you can, look at that equation. It looks complicated. There's a lot going on. And if you were asked to graph this a week ago, you'd be like, no. But once we realize the patterns that happen, it's not that bad. We need to know what our original graph looks like. So those 4 pages we did at the beginning, and I said you need to memorize that graph in the top corner. Yes, because now we can do all of these things to each of those graphs. You now have a method to graph a lot of functions quickly. And what's really neat about this is it's not just a rule for lines. Or grade 10, you spent a whole unit just on graphing lines, and you only learned how to graph lines. And then grade 11, a whole unit on graphing parabolas, and after that, you could just graph parabolas. And now, this rule, well, it works for lines, it works for parabolas, for x cubes, for sinusoidal graphs, for logarithm graphs. Any graph that someone just draws for you, you could take it and then say, I can do all sorts of things to this graph. It works for everything. So it's really powerful that way. So here on the next page, they've got some pictures for you. There's a graph of x cubed. If you wanted to move it down, it would look like that. Oh, I don't like this notation. I'm going to skip this. Let's just go to example 1. Here's our example 1, just some random graph. And they ask you to sketch and label its image after vertical compression by a factor of 1/3, then a translation of 2 units up. So one of the things that we're going to do in this question is we're going to label the new equation in terms of the function g. So a vertical compression of 1/3 would be outside the function. And 2 units up would also be outside of the function. So this is how we could translate those words into an equation. Then here we have 4 key points. We've got -5, 3, -2, -3, 1, 0, and 4, 6 on our original graph. And even though we have only 2 things to do, we're going to set it up so that we do our stretches first and our translations second. So your first, I'm going to write stretches, but it's stretches, whoa, and I forgot the E. There we go. It's stretches and compressions, and then the second one is always translations. Now you won't label this every single time, but for this first time that we're doing it, it's good to remember that we'll always do our stretches first and then our translations afterwards. Because in this situation, can you see that you have 2 things happening to your y value? And some of you are great at mental math, and that's wonderful, but you will find if you try to do more than one calculation on something, you have a higher chance of making a mistake. It's just normal, right? If I say, okay, 5, I'd like you to multiply it by 3. You'd be like, oh, that's one thing. No problem, 15, okay? So, okay, but what if we did multiple things? I'd like you to take 5, I'd like you to multiply by 3, I'd like you to add 7, divide by 2, and maybe add 4. Do you have you're like, whoa, I was good at multiply by 3, but I should write that down so that when I have to add 7, I'm like, I'm at 22, and then I'll divide by 3, now I'm into fractions. It's like, it gets more complicated if you have to do more things. So what we're going to do is we're going to try to keep things simple. We're going to say, okay, first of all, that 1/3, that's a vertical compression. Vertical compression. We're going to multiply y by 1/3. Then the +2, that's a vertical translation. That's going to go up 2. So doing things simply to begin with, y by 1/3, well, I'm going to have this point, this point, this point, and this point. And the other thing that's going to get you in this unit, okay, is so far, was the mental math difficult? No. Okay? Very dangerous, the fact that it's not difficult. So not difficult that you're like, oh, I can already start to think about the next thing I need to do because this isn't difficult. Have you ever done that on anything? Where you're doing something not difficult and you end up like starting to think about the next thing. Like I should put, you know, I just had a snack and I should put something back in the fridge, my drink. But I also should put my dishes in the dishwasher. And all of a sudden you put your drink in the dishwasher and you can't find it because you're already thinking about the next thing. I remember growing up, this happened to my mom a lot. She was thinking about the next thing, and we would have a reward. If anybody can find the butter, there's a reward. It was usually in a cupboard. You know, sometimes it was downstairs, you know, in the freezer, because she was thinking about the next thing and she knew she had to put the butter away, and that's super easy to do, but she just put it away wherever she was thinking about the next thing. Okay, and so we do this, right? We start thinking about the next thing. Maybe me and my brother were lots of trouble that it was like, you know, the grocery store. We were in a small town. The grocery store would phone. You know that you left your groceries on the curb again after you put your kids in the car. Because they were probably fighting and you were, whatever, groceries on the curb, groceries on the top of the car. You can drive quite a ways with groceries sitting on top of your car. But if you start to think ahead of what you need to do next and you don't pay attention in the moment, you're going to find that you're going to multiply y by a third here, and then all of a sudden decide to multiply your x coordinate by a third, and then like just do weird things. So we really have to pay attention, and one of the best ways to do that is to have as your next step a quick check, did I do each of them right? And now I need to go up to, so I'm going to add 2 to my y coordinates. And then my next step is I'm like, did I do each of them right? Just a quick check. And sometimes I'm even doing that quick check right after I did it. Did I do the y coordinate? Yes. Did I do the y coordinate? Yes. And if you have that check in place, you're not going to make that mistake, that easy mistake where you, oh, I just screwed up and did the wrong coordinate or something like that. So now we have 4 new points, -5, 3. Well, that's in the same spot. -2, 1 is there. 1, 2, and 4, 4. Play connect the dot. And then the last thing that I like to do as a check is I like to go back to these green things that I wrote at the beginning and ask myself, does my shape make sense for what is supposed to happen? I'm supposed to have a vertical compression, so that's on either side of the x-axis, squishing it towards the x-axis. Does that shape seem to fit that? And then moved up to yes. Overall, that seems to be good. So I feel like this makes sense. Okay? Now, normally, we just do the question off to the side, but there is something interesting that happens with the example that was done for us as well. So I'm just going to go over this one as well. And the information or the interesting thing that comes up is more in the notation than actually doing the arrows. This one's horizontal. They want a horizontal compression by 1/2, then a translation 3 units to the left. Okay? And the first thing that is going to come up, yeah, question? No, it's good. The first thing that I want to show you that you could have thoughts about is I want you to think, which do you think is the right way to write this in terms of f? Okay? Compression by 1/2, that's going to be inside the function. Everybody okay with that being a 2? Okay? So I'm going to give you 2 options and then 3 units to the left. I'm going to give you one option, 3 units to the left like this. I'm going to give you the other option of 3 units to the left like this. So, first of all, do we notice that they're different? And sometimes you can write something different, but it's actually the same thing. But these ones are actually different. Because this one, if you multiplied it out, would be 2x plus 6. And the other one is 2x plus 3. One of them is right, and one of them is not right. One of them moves it 3 to the left. The other one does not move it 3 to the left. Okay? So one of the ways you could try to figure out which one's right is we've done our beginning example, which had 3 to the left. Notice how it was written. Okay? Notice that that 2 was not distributed to make 2x plus 6 inside. I would say this is written in factored form. So when we go to the question that we're doing, this one is correct. This one is wrong. This one would only shift it 1.5 units to the left. doing the points and doing the compressions and stuff would be exactly the same, right? You would, I'm not going to do that right now. You could do like this and x by a half and 3 to the left, and do that for each of the points. That would be exactly the same. But the important thing is how it's written. And so we're going to add at the bottom of this page a special note. And in your special note, you're going to say, when you have horizontal either stretch / compression / reflection, and a horizontal translation. And this doesn't matter with vertical, just with horizontal. You must write it in factored form. We're not going to actually graph this, but just the setup. If you were asked to graph negative x plus 2 inside of a square root, can you see the negatives inside the square root? That would be horizontal, a horizontal reflection. Okay? The plus 2, you're going to want to go 2 to the left because you see the plus 2. But this isn't written in factored form. So you would have to first factor out the negative, which would give you x minus 2 inside the bracket. This would be a horizontal reflection and 2 units to the right. And this is going to be something that's going to get you. Can you see that already? You're going to be like, oh, plus 2 is so easy. That's 2 to the left, and I'm going to go to the left. Okay? I had one student one year set a reminder on their phone for 10 p.m. every night with this note. Okay? Because they say, you know, in order to learn something, they say, well, you need to know, like, you have to be reminded of it like a minimum of 7 times before you get to know it. I don't know how many, like, math reminders they set by the end of the year, but this was one of the ones. And so 10 o'clock, oh yeah, I've got to remember to write it in factored form. And that was a little bit of studying for them over and over and over again so that by the end of the year they had it. I'm not sure if that's something you want to do. You're going to be like, oh man, from 7 o'clock to 11 o'clock, I'm going to get reminders of all the things I need to do. This is going to take up so much time. But this is one of the ones that you will forget, you will make mistakes on, and it's really easy to forget, because especially if I just put a negative out in front, it looks so harmless, so tiny. It's not even a number really, that you're going to forget to write it in factored form. Okay, questions for practice 4, 5, and 6.